Hello, everybody. Welcome back. This is Unit 2. Unit 3. I'm always getting confused. Unit 3, compounds. So far we've learned all about atoms. So we've learned about how the basic structure of atoms and some of the most important information about electrons, like the fact that they come in specific rings or shells or orbitals, and that the most important are the valence, and that atoms can either accept or donate electrons in order to become positively and negatively charged ions, called cations for positive and anions for negative. This unit, we're going to be focusing all about putting those together. So how is it that atoms come together to form different compounds? So let's start diving in and taking a quick look at that. I want to show you your notes first. Let me pull this up. Okay. All right, so here are your notes. So I wanted to give you a quick overview. This unit is going to be a little bit different than last, not by too much. We have a lot of stuff to learn, but once you've learned it, it's just going to be a lot about practicing. So sorry, let me just zoom this in a little bit. We can make this just a little bit better. There we go. Okay, awesome. So the first thing are some vocabulary terms that you're going to need to know. So we are going to need to know about metals versus nonmetals. If you remember, these are all marked off on your periodic table, right? All of these elements are nonmetals. Everything else is a metal, except for hydrogen, which is mostly a nonmetal, but technically can be a metal, but mostly a nonmetal. It's a little confusing, but just remember hydrogen can be a little bit funky. So that's the basics there that you need to know. Okay, so metals become cations because they tend to donate electrons, and nonmetals become anions because they tend to accept electrons, so they end up being negatively charged. There are two types of compounds. There are covalent and ionic compounds, and a lot of this unit is distinguishing the difference between the two. This unit in general is extremely foundational. You are going to be needing to learn how to identify ionic versus covalent compounds, first of all. And then second of all, figuring out how to write their names or write their formulas. So you're going to go back and forth between the two. Because in chemistry, we use both. If we're talking about something like sodium chloride, then we would give the name. If we're writing it, we tend to write the formula, which is NaCl. We'll get into how we do that. That's this whole unit. I'll give you a little, it's not really a warning, just my observation. For some students, this unit is really easy. It just kind of makes sense and comes naturally. For other students, this is a little abstract. And it's kind of abstract because it's all about ratios and it's about really understanding and having a visual picture of what's happening. It might take you a while to learn this. For some students, you might not really 100% get it by the end of this unit. But if you stick with it, it's okay. You'll get there eventually. And even if it takes you a little bit longer, don't worry about it too much. You will get there eventually. We're going to do a ton of practice to help you get there. So the amount of actual information you need to know is not really that much, but it is extremely important. So let's talk about the difference real quick. So a covalent compound is where the molecules or the atoms that are involved in making the molecule have more than one nonmetal, no metals, and they all share electrons. Ionic compounds are made of a metal and a nonmetal together, or a polyatomic ion instead of a metal. And they donate or accept electrons. So they don't share them, they just kind of, one atom gives the electron away and the other accepts it, and they kind of both move on. So that's the really key difference. Actually, with that in mind, there is a link to a video right below this one. I'll show you what it is really quickly. Stop this share. It's just going to take me 1 second to find it real quick. I got to go to my YouTube channel. Oh, I'll share with you getting to my YouTube channel. Why not? Just in case you haven't seen that in a while. All right, let's share that. So if you all go to my my YouTube channel, Mr. African Science, and let's see if I have a playlist created for you all. Otherwise, I'll pause this video and create the playlist. Oh, there we go. There are the playlists. Let's see. Okay. You know what? I don't have one yet. So 1 second. Okay, I just fixed it. So let me share it with you now. Okay, so I just added a new playlist to the YouTube channel, and this video is right here. Again, I'm going to have a link in the doobly-doo below for this one, for the comments. But here it is. It's called How Atoms Bond. It's a TED Ed video. I'm not going to show it to you in here. I'll click on it real quick just so you get a little see of what. Not good with my language. No, gross. Never mind. Anyway, it's a great video. You should definitely check it out after the after the ads work. Please go check that one out right now. And then so pause this video, watch that one, and then come right back. Okay, so hopefully you checked out that video. What I really love about that is that it has all those great visuals of the difference between ionic and covalent compounds. So you can really tell, like, I think they refer to it as the type of sharing where you give someone your toy and they never get it back again. So that's very ionic, passing electrons back and forth, and that's it. Whereas for covalent compounds, it's like a tug of war. They both want them, neither one's going to give them up, so they share them. Covalent means like together, valent. So valence electrons together kind of makes sense. Okay, so that's a really important concept to know. Let's get back to the notes, looking at them. So ionic versus covalent, definitely a really, really big deal. We'll keep kind of going over that together. So back at the notes, there's two other things that I just wanted to go over with you. Polyatomic ions are going to come up later, but these are ions that are actually covalent molecules that together operate as if they were another type of ion. So you're going to want to be able to spot those. And crystals are what solids look like. Solids are, or crystals are like when solids have a regular pattern that forms what they look like. So like if you looked at salt crystals under a microscope, they'd have this regular pattern where every other, like they showed in the video, it's a salt crystal. Normally during a unit, we would do a lab on crystals for this unit. Is it this unit? No, it is not this unit. Never mind, I lied. It is a later unit. If we are not back in school in time for that, we'll go past it. And when we do get to come back, we can go straight to that lab. So we're going to make up labs as we go. But in the meantime, let's blaze on forward. So what I want to do before we get into all this other stuff, let me just cover that because we don't need it. I want to go through a couple of examples so you can see if you can figure out ionic versus covalent. So I'm going to write down a few formulas. So we'll talk about formulas in some of the next videos, but a formula is using the symbols to write out the type of compound. It always lists what elements the compound has and in what ratios. So how many of each you can find. So let me just throw one out at you here. Okay, so this is called magnesium oxide. You don't know that yet, and that's okay, we'll get there. But it clearly has one Mg and one O, so that's magnesium and oxygen. So the question here, is this ionic or covalent? So let's take a look at our periodic table. We'll find both elements. The first thing is, here is magnesium, and here is oxygen. So ionic compounds, going back to the notes, ionic compounds have, covalent ones have more than one nonmetal with no metals. Covalent, or ionic, oh, goodness, I'm getting confused. Ionic have a metal and a nonmetal. So magnesium is definitely a metal, it's in the metal section, and oxygen is a nonmetal. So this is ionic. And that's all you have to know for right now. Not bad, not too bad, right? Okay, let's take a look at another one. Okay. One thing you're going to notice here is that you always write this, if you have a symbol that has more than one letter, you always write the second one as a lowercase, and that's actually really important. And there's a specific reason for that. If you have some of these elements, if you write the second letter as a capital, it might be confused with another element. So for example, silicon is SI. If you put S, capital I, there actually is an element that has a capital I, which is iodine. And there's an element that's a capital S. So how do I know if it's sulfur and iodine or if it's silicon? I don't. So definitely be careful of that. All right, so back to this. I always got to talk about that because it's important. Okay, so here's another compound. This has an S, which is a sulfur, and it has 4 chlorines, which is here. All you got to recognize for right now is that it contains sulfur and chlorine. So do we think this is ionic or covalent? Well, sulfur and chlorine are both nonmetals. So if you look here, covalent compounds, more than one nonmetal, no metals. They're both nonmetals, definitely covalent. Okay, so that's the basics. It gets a little bit trickier as we go on, but that should at least kind of give you an idea of what we're talking about. All right, great. So there's no unit packet pages associated with this, but we are going to continue on learning about how to write the names of covalent compounds. So this is a formula for a covalent molecule or compound. The name for this one is actually sulfur tetrachloride. You're going to learn all about how to name it. We're also going to learn how to write the formulas for covalent molecules. So again, SCl4 is the formula. We're also going to do the same thing for ionic compounds. It is different. Naming and also writing the formulas. And then we're going to talk a little bit about polyatomic ions, which are not on here, but we'll have some space for that. I'll throw them in here somewhere. Transition metals, and then that's pretty much the whole unit. So there we have it right now. I will see you all in the next video. Hopefully that was somewhat elucidating and a decent introduction. Catch you all on the flip side.